Let's have a look at some answers here. Okay. Now, I don't know how everybody didn't get the first one right. I gave you the answer.
Oh my God! I didn't know. I got all the second ones wrong. I got all the first ones wrong.
All right. So the first one, remember I gave you the answer. I said the slope was 2. Okay. The next one, the slope should be 0. It's flat. The average acceleration is the slope. It's flat.
Well, I said
Right?
I put 0. I got it
The
right.
slope is 0.
Number one?
Number 1, the slope is 0.
Why did I get it wrong?
I don't know. You didn't put 0.
You got it wrong. You told me it was negative.
Did you put 0 for number 2? Well, that's why you got it wrong. 1 is 2. 2 is 0. All right. Number 3. The correct answer is -2. C is -2. It goes down 4 over 2, -4 over 2, or -2.
Doesn't it go all the way down to -2?
C is only from there to there, Matt. C is from 5 to 7.
That makes no.
C is from 5 to 7. D is from, the next one, D is from 7 to 8.5. D is from 7 to 8.5. Okay, now D is the same. How come it's the same? Because it's a straight line. It's a straight line, right? -2. D, the slope is 0. It's flat. Right? Oh, sorry, that's E, right? That's E. And F is positive. It's up. I go up 3 over 3. I have a slope of 1. Okay? Remember, in all these cases, we're talking about the average acceleration. All right, now I'm guessing things got a little bit worse.
All of them wrong.
Let's pay close attention then. Listen carefully. Tristan, I need you to watch so that you don't get this wrong later. Now is the time to listen. When does this object stop? The correct answer is G. Never. Why is it G? Never.
Because it's always going like 4 meters per second.
Yes, it always has a velocity, right? In interval A, it goes 0, 1, 2, 3, 4, speeding up. In interval B, a lot of people probably put it with stop, but that's if it's a position time graph. Because it's a velocity time graph, it has a constant velocity of 4. It has a speed of 4. Here the speed is going down to 0, here the speed is negative, here the speed is -3, and here the speed is changing. There's always a speed. Now, having said that, I know what's coming next. There are instances right there and there and there when it is momentarily 0. Okay, but it asks you for the intervals when it is stopped. Does that answer your question?
I was just going to ask if there's any possible way it could be stopped.
The only way it would be stopped would be if the velocity time graph was flat at 0. Right? Flat at 0. Well, that's why I'm teaching it.
Is it not stopped the exact point where it hits that line?
Momentarily, yes. Momentarily, right? But it's asking for what intervals. Okay, so the answer is G. Now, this is even harder. Watch closely, Tristan and Bray, so I don't have to explain it later. Turn around, Tristan. They don't need to see your clicker. When is the object moving backward? Moving backward means
Yes.
Negative.
negative velocity. Negative velocity, which means D, E, and F. D, E, and F have a negative velocity. There's F right here. It's a graph of velocity, Bray. It's a graph of the velocity. Remember before we talked about position time graphs? These are different. These are velocity graphs. A graph of the velocity. So moving forwards then, number 9, slowing down. Slowing down means that the velocity
How do you get slower than a stop?
is going to 0.
Or is this just here?
There's no position where it stopped.
I know, but like for negative velocity, does that mean going past 0?
No, that just means going left. right? So slowing down means the velocity is approaching zero. When does it approach zero?
C and G.
Right there, it's going towards zero, and F, right there, going towards
I
zero.
put CD.
You would be wrong.
I got C though. C's right. isn't it?
C and F. The velocity has to be going towards zero.
So I was-
Gage, are you listening? Because I know I'm going to have to re-explain this later.
Yeah.
In fact, I can, okay, when the velocity goes towards zero, going towards zero here, going towards zero, going towards zero here. Now, the flip side of that is, when it's speeding up, it's when the velocity is moving away from zero. When is it moving away from zero? At A and D. A and D. I'll maybe put those in red so you can see them better. Now, you will notice that in C, it is slowing down, and D, it is speeding up, even though the slope remains the same. It just means that it's changing its speed at the same rate. The velocity goes 4, 3, 2, 1, 0, slowing down, and then it goes 0, minus 1, minus 2. So in other words, it's going forward and slowing down, and then speeding up backwards, okay? Imagine me throwing a tennis ball at the wall kind of thing, right? Slowing down as it hits the wall, and then returning and speeding up as it leaves. Okay? Real important questions here. Do you think I'm going to ask you this stuff? Do you think I'm going to expect you to know this come test day? Absolutely. If you haven't put a big star beside this, you should do that. Because this is important stuff. When is the object moving at a constant speed? Constant speed means the velocity is not changing. Right there. The velocities are constant. Okay? You have to think about these being velocity time graphs, not position time graphs. Okay? Make sure you include this in your study guide, this kind of stuff. Important stuff here. It'll be about a week or so. Yeah. Yeah. Well, we need to have one, Ben. It's been a while. Yeah. Okay, now I'm going to talk about displacement. Okay? Displacement is how far it goes in what direction. Pardon me?
How B and E.
B and
When it's
E.
flat. When it's flat. Okay. Displacement on a VT graph is determined by calculating the area between the graph and the time coordinate. The area. The area. Displacement is the area. In the example, the displacement for the time interval 0 to 2 seconds would be equal to the area of the triangle formed by the graph and the time coordinate. So I'm talking about interval A, which is from 0 to 2. Okay? I am talking about that gray triangle. That, my friends, is the displacement. Okay? Let's just look at this a little bit closer by zooming in.
I wish I could do that.
0 is my initial velocity. What's my final velocity?
4.
4. When is it moving 4?
2.
Only at the end, right? It goes like 0, 1, 2, 3, 4. Okay? What's the average velocity for that time? 0 and 4. The average of those two is 2. Over 2 seconds is a displacement of 4 meters. Now, conveniently, it works out to being the area of that triangle. Why does that work out? Well, you think about the area, or the average between 0 and 4, it would be like me doing that, wouldn't it? And the area of that rectangle would be 2 times 2 or 4. And in fact, what I'm really doing is I'm taking this little triangle here, right, and I'm taking it off, and I'm just, whoopsie, and I'm just flipping it upside down, right? That's all I'm doing, right? And so the displacement is the area of that gray triangle, which is a base of 2, a height of 4, half the base times 2 times 4 is a displacement of 4. The displacement right here is 4. You are going to remember, Ben. You're going to have to. If there's no triangle, then it's going to be a rectangle. If there's no rectangle, then you have to cut it into triangles and rectangles.
So I was really going to ask you like 2 to 7, yeah.
Bless you.
That wouldn't you just know because it's 0 to 4? And you would just know because like 4 minus 0.
No. No, 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 no. No, 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 no. It is not 4 minus 0. This is velocity. It's not position. It's not position. Okay? Now, if there's more than one interval to be used, then you simply add them up. In other words, if this is interval B, and it is, right? Now we have a rectangle. What's the formula for area of a rectangle? Length times width. So I've got 2 to 5 is a length of 3, up to 4 is a total of 12. Okay? The base is from 2 to 5, that's 3. The height is from 0 to 4, that's 4. 3 times 4 is 12. Add on the original 4, I get a total of 16. Those two are 16. These two. Okay?
Wouldn't you be able to do that by like multiplication?
How?
Like equation of some sort, actually, the number? Is that
Well, you'll notice that the average is still 2, right? Right? The average of 0 and 4 is still 2, times 5 is 10. How come it doesn't work? It's because it's not a constant acceleration. That only works when you've got one sort of straight diagonal line, okay? When you've got two shapes, you're going to have to do it this way. Two shapes. Okay. Now, what if the displacement is below? What if the velocity is below? Negative velocity means it's moving to the left. So, if the graph is below the time coordinate, Matt, then the displacement is going to be negative. When is it below? Well, interval D, right here. Interval D is right there. Right? So, what's the area? Now, notice this. Here, the shaded area is above the graph. Above the graph, not below, above. Okay, see there's the graph right there? I go above. I'm always between the graph and the y and the x-axis. Between the graph and the x-axis. So in this case here, it's 1/2 of, what's the base here? From 7 to 8.5 is a base of 1.5. 0 to minus 3, so it's 1/2 the base, 1.5, times the height of minus 3, minus 2.25.
Why is it half?
Because it's a triangle. It's half the base times the height. Right? Half the base times the height. Guess what's coming next?
Isn't it easier to do base times height by 2?
Is that not the same thing?
Yeah, but it's easier.
Okay.
More questions?
I would like you to find for me intervals C, E, and F, the displacements. For C, E, and F, the displacements. C, E, and F. Very quickly, watch carefully. So interval C is this triangle right here. Interval C is this triangle here, so the base is from 5 to 7. That's a base of 2. The height is from 0 to 4. 2 times 4 divided by 2 is 4. Chandler, listen. E is this rectangle here, right? E is from there to there. The base is 2.5. The height is 3 minus 3 divided by 2 gives me an answer of
7.5.
minus 7.5. F is this triangle here, right? We're talking about a base from 11 to 14. That's a base of 3.
I got all the numbers right. I just didn't put the negatives.
Right? Base of 3. The height is minus 3 divided by 2, minus 4.5.
I have all the numbers
Okay.
right. Just put the wrong sign.
What are the chances that I'm going to ask you to do that on the test?
100%.
100%. I guarantee it. You have to be able to do that. I guarantee that.
See, the thing is, it's easy to do, but it's when you ask us how we know which one.